Okay, so we're going to calculate the oxidation numbers, or oxidation number of a carbon atom. And as we do this, we've got to remember our electronegativity series. And generally, fluorine's more electronegative than oxygen, which is more electronegative than nitrogen, which is more electronegative than bromine, chlorine, and carbon, and hydrogen. So we can see that carbon is here. Every bond between a carbon and another carbon atom does not alter the oxidation state or oxidation number. Every bond between a carbon and a hydrogen atom will decrease the oxidation state by 1, and every bond between a carbon and a more electronegative element / atom will increase the oxidation state by 1. So, having set those ground rules out, let's have a look at methane. And if we look at methane, we know we've got a carbon bonded to 4 hydrogen atoms. And each hydrogen atom will be +1, so we have +1, +1, +1, and +1. So consequently, the carbon in the middle must be -4 oxidation state, because +4 and -4 gives us 0 as our desired answer. If we look then at carbon dioxide, here we got C, double bond O, double bond O. We see the oxygens are -2 and -2 because there are 2 bonds. So consequently, the middle carbon is +4, so this is the oxidation state, +4. So one can say that this is one of the most oxidized, as over here this is the most reduced form, So that's pretty cool to see that. Now we take a look at some other functional groups. We can see some other applications of this. If we look at a carbon attached to a terminal end, obviously now this is +1, +1, +1, and this is 0. So clearly now the carbon here has a -3 oxidation state. If we look at a double bond, we'll put 2 hydrogens on here to indicate what's going on. We have +1 and +1, and this is 0, so consequently the carbon here must be -2. Look a little further down, we're going to look at an alcohol. We'll make this a primary alcohol. I'll put the 2 hydrogens in. So we can see that we have, make sure we got +1, +1, and -1. So over here, this must be -1, because obviously over here we have 0. So that's a -1 oxidation state. If we look at an aldehyde, here we have a center, we've got +1, minus 2, and this is 0. So clearly over here we must have plus 3. Is that correct? Minus 2 plus 1. So plus 1. I apologize. That's plus 1. And then finally, at the bottom, make sure I've got enough space. We look at our carboxylic acid. Here we have it. We have minus 2, minus 1, plus 1. So that makes this a plus 2 oxidation.